All right, let's crack the code on software testing. Today, we're diving into the ISTQB Foundation syllabus. Think of it as the official map for anyone who wants to build high-quality software that actually works. It's the global standard, and we're going to break it down. You know the feeling, right? That banking app that just dies, the game that glitches out at the final boss, or that document you were working on? Poof, gone. It's frustrating, it's universal, and frankly, it doesn't have to be that way. There's a whole professional discipline designed to prevent exactly that from happening. And this is it, the International Software Testing Qualifications Board, or ISTQB for short. It's the organization that sets the global standard for how to find those annoying and sometimes critical bugs before they ever get to you. It's basically the common language that unites quality experts all over the world. So, here's our game plan for this explainer. We're going to cover the 6 big areas of the syllabus. We'll start with the why, then get into the core principles, the practical steps, the tools of the trade, how it's all managed, and finally, what a career in this field actually looks like. Okay, first things first. Why do we need a whole formal process for testing? Well, it's about way more than just fixing typos. We're talking about preventing everything from a tiny glitch to a catastrophic failure that could cost millions. You have to understand this chain reaction. It all begins with a human error. Someone makes a simple mistake while coding. That mistake creates a defect in the software, which is what we all call a bug. And then, when the code with that bug runs, it can cause a failure, the crash, the freeze, the wrong calculation. The whole point of testing is to find and fix that defect, breaking the chain before it leads to failure. Now, here's something people get mixed up all the time. Testing versus quality assurance. They are not the same thing. Testing is about finding bugs that are already there. It's corrective. Quality assurance, or QA, is the bigger picture. It's preventative. It's about fixing the process so that fewer bugs get created in the first place. Testing is a crucial part of QA, but it's not the whole shebang. All right, let's get into the mindset. What makes a great tester? Well, it starts with these 7 principles. This is like the DNA of the profession. These core beliefs guide every single decision a tester makes, and they are absolutely fundamental. This first one is a big one, and it kind of messes with your head. Testing can prove that bugs exist, but no amount of testing can ever prove that there are no bugs left. It's impossible. So the goal isn't to create perfect software. The goal is to find the important stuff, reduce risk, and build confidence that the software is good enough to release. So if you can't prove there are no bugs, why not just test every single possibility? Well, because you can't. Think about a simple login form on a website. Testing every possible username, password, browser, and network speed would literally take forever. Since testing everything is impossible, the pros have to be smart. They use techniques to focus their efforts where it matters most. And this is where it gets really interesting, especially for the business folks. Finding a bug early, like when it's just an idea on a whiteboard, might cost a few dollars to fix. Finding that exact same bug after the product has launched, it could cost thousands or even millions in developer time, customer support, and lost reputation. It's a no-brainer. Test early, test often. You know the 80-20 rule, right? Where 80% of the results come from 20% of the effort? Well, it totally applies to bugs. It turns out that most defects tend to hide together in a few specific parts of the code. A skilled tester knows how to spot these bug clusters and can focus their energy there for maximum impact. This one's got a cool name, the pesticide paradox. Think about it. If you keep spraying the same pesticide on a field, the bugs eventually become resistant. It's the same with software tests. If you run the exact same tests over and over, they'll stop finding new bugs. To stay effective, your tests have to evolve along with the software. There is absolutely no one-size-fits-all strategy in testing. The way you test a fun mobile game focusing on performance and user experience is completely different from how you test the software that runs a pacemaker, where safety and reliability are literally life or death. The context, what the software is for, changes everything. And finally, maybe the most important principle of all. You could build the most technically perfect, 100% bug-free piece of software in the world, but if it doesn't do what the user actually needs it to do, it's worthless. It's a failure. The ultimate goal isn't just about building the product right, it's about building the right product. So, with those principles as our guide, where does testing actually happen? The old way was to wait until the very end of a project, right before launch. We know now that's a terrible idea. Real quality is built in at every single stage of development from day one. The easiest way to picture this is to think about building a house. First, you have component testing. That's like checking every single brick to make sure it's solid. Then you have integration testing, where you check if the bricks work together to make a strong wall. Next up is system testing, where you check the whole house, the plumbing, the electricity, does it all work together? And finally, you have acceptance testing. That's the final walkthrough where the new owner says, yep, this is exactly the house I wanted. This all ties into a simple but revolutionary idea called shift left. If you imagine a project timeline from left to right, instead of cramming all the testing at the far right end, you shift those activities as far left as possible. You start testing ideas, designs, and requirements right at the beginning. It's all about that test early principle in action. Okay, so how do testers actually find these bugs? It's not just clicking around randomly and hoping for the best. They have a whole toolkit of powerful, structured techniques designed to systematically pull those defects out of hiding. Let's look at the two big categories. First up, you've got black box testing. Imagine you're handed a new TV. You don't take it apart to look at the wiring. You just grab the remote. You give it an input, pressing the power button, and you check the output. Does the screen turn on? You're testing what it does from the outside without any knowledge of how it works on the inside. And then you have the complete opposite, white box testing. This time, you're the mechanic with the hood open. You can see the engine, the code itself. You're not just checking if the car drives, you're tracing the fuel lines and checking the spark plugs to make sure every single internal path works exactly as it was designed. A truly good test strategy uses both. This all leads to a really crucial point. Professional testing is not an art form. It's a disciplined, scientific process. It's an engineering discipline, just like development. It's structured, it's managed, and it's designed to get predictable, reliable results. It's not chaos. And that process follows a really clear cycle. You start with planning, what are we trying to achieve? Then you move to analysis and design, how are we going to test this thing? Implementation is where you actually build the tests. Execution is the part everyone thinks of, running the tests and seeing what happens. And finally, completion, where you report on what you found and wrap everything up. So, after all of that, let's bring it back to the real world. This isn't just a bunch of theory. The ISTQB framework is a globally respected career path that lets you grow from a beginner all the way to a world-class expert. The foundation level, which is basically what we've just covered, is the launch pad. From there, you can go into the course stream to become a test manager or analyst, or you can branch out into the Agile stream, or dive deep into specialist topics like security testing, automation, or usability. It's a full roadmap for an entire career. So we'll leave you with this question. Our entire world is being built on software. Everything from our banks to our hospitals relies on code. So in a world built on code, who's going to make sure it's built to last? Who's going to ensure it's safe, reliable, and actually does what it's supposed to? Well, that's the job of the software tester.